All right, so my name is Annuka Paulsen. I'm a process control group leader at Kapstone, paper mill in Charleston, South Carolina. Let's see if I can figure this out. Okay, so Kapstone is was founded in 2005 as a special acquisition corporation by Roger Stone and Matt Kaplan, and has since then grown into including 4 paper mills, 23 converting facilities, and 1 lumber mill. Annual revenues are about $2.1 billion, and we employ about 4,500 people. Our product lines in the paper mills are all brown papers. They include a DuraSorb saturating kraft, which is used for laminates in countertops and flooring. Kraftback is a cardboard grade used for beer carriers and pizza boxes, and when we have a liner board and corrugated medium grade that's used for boxes. And I'm here today to talk about a Foxborough DCS upgrade in our pulp mill area. And for any one of you who may not be familiar with the paper industry, the pulp mill is the back end of the mill where you take the wood chips and the caustic liquor, mix them and cook them high pressure, high temperature for a few hours, and dissolve the lignin glues in the wood to separate the fibers out of the wood. And then you have to take that out and wash the dissolved solids and send the fibers to the paper machine to make paper out of them. So our mill is an older mill. It was built in 1937. So even though Kapstone is a young company, we've been around for a while, and the system is a mix of older technologies and newer technologies. And the pulp mill itself is now technology-wise probably one of the best we have, but there's a lot of old equipment still around. The challenge we have with this upgrade is that we needed to upgrade our obsolete hardware, HMI software, PLC interface, and a control configurator during a mill outage. Our paper mill is a 24/7 operation. We only go down for complete shutdowns once every 3 years, and that shutdown will only last 2 or 3 days. So the pulp mill, because it's serving 3 paper machines, can never go down except when the mill is down. So we have a very short time period to do any real work there. The pulp mill DCS system was put in 1992 as a Unix-based 3-node system and has since undergone several upgrades, software and hardware. And maybe the 2 most important ones would be the Y2K upgrades. And in 2007, we took our first steps towards a Windows-based platform. We put in 2 Windows servers for boot host for the CPs, upgraded the CPs, and put in some mesh switches. So after that, it was a hybrid system with both Unix workstations and Windows servers up until 2013, when we took the last Unix stations out of service and became a secure Windows-based system. So that's what I'm really going to talk about, is this latest upgrade that we did about a year ago. And what I want to emphasize is since we have such a short time period to make anything happen, we wanted to step back and think about what, if anything, can we do ahead of time. The process itself started in 2011 when the decision was made that we were going to do this upgrade. And when money was released in 2012, we started buying the servers and decided that since we had done the 2007 upgrade with the mesh switches and a hybrid system, the workstations could be relatively easily upgraded on the run with minimal interruption to operations. And so we went ahead in the fall of 2012 and built all the workstation servers offline and deployed them. At this point, we upgraded our display manager to FoxView, the HMI software, and our legacy historian to a Wonderware historian. Our boot host at this point remained at the older Windows version, which was unsecure, versus the workstations were set up as secure servers. And our engineering tools remained at the original integrated control configurator. So the initial decision had been to upgrade everything, including the control configurator. And then somewhere on the line, we got cold feet and started worrying about upgrading the largest system we have in the mill to something we don't know anything about. But as we were building these servers and learned more about how this system works, we decided that we really need to explore this further, because if we don't do it now, we got to do it 3 years later anyway, and what's the real point in waiting? So in August of 2012, I attended a Foxborough users group meeting in Boston and had the opportunity to talk to some people who had done this migration on their own, as well as the Foxborough developers and engineers, and saw some demos on the software and got a better flavor for what it can do for us. And at this point, we decided that this is really the path we want to try to follow. So instead of going from the line by line, enter every data point on your own, you get a visual interface which gives you a lot more tools, and just the feel of how it works is better. And after that, I attended a 1-week class on Foxborough tools and got a little more feel for it too. So at that point, the deal was sealed, and we were going to do it, and we're going to do the upgrade in-house ourselves. So in November of 2012, we started the process of the upgrade. In January 2013, we were more or less done, at which point Foxborough released the following version, which is version 8.8, that was going to open up a whole new set of tools in the future, including virtualization and USB keyboards that we were very interested in. And then at the same time, our mill outage that was supposed to happen first week of February was moved to May. So at that point, we decided that, hey, we're going to go do another upgrade. So all of this boiled down to just a lot of preparation. We took all our spare parts that we could find and built a test bed. And so we set up servers for a boot host, for a Galaxy engineering workstation, for a historian, and for a primary domain controller, since we were setting it up as a secure system. And we also included some switches and CPs and FBMs for testing purposes. We also set up an image of the existing boot host server with the ICC configuration tools, so we could compare the two systems, and downloaded all possible manuals and instructions on how to go about this conversion. And the execution itself starts with getting an image of the existing database, or save all, and bringing it into a bulk data import into the new control system. And while you're bringing in the control system, it creates a text file with how this import is going, and it's well worth taking that text file, putting it into a WordPad, or whatever you have, and check for anything that says fail or error. And if there's anything that says fail or error, start over, go back and fix it. And we decided to make all our changes that we could in the existing running system, because we didn't want to have any surprises afterwards where we might have made some changes on the test bed, and then finally when the day came and something didn't work, we didn't know if it was a problem with the changes we made in between or if it was something wrong with the conversion itself. So it's an iterative process. You have to go through this process a couple of times, and every time you do it, you learn something new about it. And once you're done with all these comparisons and testing and fixing, you start with the testing process itself. So on our test bed, the first thing we did, we took an image of the existing save all on the running system and a new converted database that we had just finished. And the save all validation tool that was available to us would flag anything that was different. And at this point, it's very important to understand what is important in the system, because certain things like default values in alarm priorities may come out different, because in 1992, the default value in ICC may have been a 0, whereas FCS forces a 5 to 1 range, so it would default it to 1. And all of these would come out as differences. And if the alarm's not used, it's obviously not important. But then there are other things that may have been out of range. We had certain temperature transmitters that were scaled 200 to 400 degrees Fahrenheit, and they were intelligent Foxcom transmitters that were able to pass data through that way out of range. So we had changed the out of service variable to 120 degrees. And of course, this didn't work. And our operators were getting alarms left and right because of that, so we decided that the right thing to do is to go rescale the transmitters, which was better anyway. And after we figured out all these things, we started testing with the hardware. We downloaded the software on the FCS and downloaded to the CPs. We started testing communication from the boot host to the CP, obviously. CP to CP, we're toggling bits, forcing analog values, making sure that they were reading from one block to another, made sure that they showed up on displays and you could trend, that the values were changing in your trends. We did some extensive testing on code functionality, specifically on sequence code and ladder logic, because we have a very complicated sequence code set up for our batch digesters. And that was probably the biggest worry we had, that wasn't going to work. So we made sure that there wasn't going to be any surprises there. And then when we finally came around and we ran the system definition through all our servers and turned all the systems on, rebooted the CPs, and everything came up, and we had minimal problems at that point. And out of all of this that we came out with for recommendations would be prepare, face your approach, spread the work. Don't try to do it in 1 week, and learn as you go, because it's especially, we kind of started off with not knowing a whole lot about the new program, and we were learning as we were doing it. So in a way, it was great because we really learned to use these tools. Document everything while you're doing it, because you're going to have to go back later and review and maybe repeat. Automate as much as you possibly can. You learn to use direct access in the case of Foxborough. Use scripting, use Excel and Word for filtering and sorting data, searching for errors. That will tremendously reduce the time that you're going to have to do this. It will reduce the amount of typos that you're going to fat finger in. And it will allow your conversion to happen more easier and quicker, and you can repeat it easier when you have to go back and do it the second or third time, or when you want to come back a year later and do a second system. And then one thing that wasn't available to us at the time, but we would probably do next time around, is Foxborough now offers a virtual CP in a virtual environment, which would reduce the need for using all this hardware that we had to do to use our test bed. The benefits we're getting out of these upgrades and staying current with the current technologies are obviously that we understand our systems and we can support them better, but also the software that is available with this new control software is more user-friendly. It's a visual interface that helps you with troubleshooting, because you can immediately determine what is connected to what. There are calc blocks have an insert step option, which was not available in integrated control configurator. And obviously, anybody who ever had to retype 50 codes of text because you had to insert the line is very happy about this. Same thing with PLB blocks. You can copy-paste. Makes the engineer's life a lot easier. You can you can build your strategies and blocks ahead of time and not deploy them. You can deploy everything at once, which makes changing code easier without interrupting operations. And also you can install the control tools in more than one server, which helps if you have more than one person working on the system at the same time. Our system now, due to the work we've done, is better positioned for future upgrades. We're going to be able to utilize things like virtualization and go forward with that. We're using thin client workstations in remote locations instead of having to install PCs or servers in dirty, hot areas in the mill. Our reliability is higher. We were able to remove the older Unix workstations that were obsolete, and we were having to buy spare parts from third-party vendors and eBay and various other places to stay online. And we're utilizing the unified security model provided, that is Microsoft basically using group policies and passwords to control access based on your login. And by doing this conversion in-house, we feel like our comfort level in being able to support this system is considerably higher than if we had let Foxborough do it. Now, I'm sure they'd be more than happy to do the work for you, but I feel like I learned an awful lot from doing this, and it really wasn't that difficult in the end. There's some legwork that goes into it, that you have to be committed, and you have to do your homework, you have to prepare, you have to read the manuals, talk to people. There's plenty of help out there, you just got to be able to find it. And of course, the upgrade cost is lower when you do it yourself. Now, some future plans we have for this system is we need to upgrade our I/O. We have a lot of 20-some-year-old I/O out in the field that eventually is going to become obsolete. So we have a multi-year plan going forward where we're looking at options of upgrading our I/O one at a time. Since we only can do it once every 3 years, we can't do it all at once, and we're going to go forward with starting that process during our next mill outage in 2016. We're in the process right now on installing HART-enabled FBMs to replace some of the older intelligent transmitters, the Foxcom transmitters that have become obsolete and are very hard to support right now. And we're rolling out that process as we're talking. Not online yet, but they will be hopefully in the next month or two. We're looking at options of adding operator links for documents such as training documents and startups to the displays. Our operators have been asking for this for a while, and we're looking forward to being able to help them out with that. And we're also looking forward to being able to tie we have 8 separate nodes in the mill that are separated geographically, and they're standalone right now, and we want to be able to pass data from one to the other, because the mill in the end is one big entity. All departments affect each other somehow. So if we can pass the critical variables from one area, say from the chemical production area to the pulp mill, so we can control the pulping variables better, because we know what the liquor quality is, it will help the mill in general. So we're looking forward to all these options that are going to be available to us due to the work we've done and being able to stay on top of it. So that's all I have today.